Guys, we are going to use function notation. We're going to find input and output. Okay, so this is what function notation looks like. It's got this crazy little f with the parentheses and an x in it. Okay, we read that as f of x, that little f with the parentheses. So f of x equals x plus 2. And for a lot of the time, it is pretty much just like y equals x plus 2. Okay, the difference is that f of x is a y with a promise that the rule is a function. So when I say rule, I mean we're assigning output to input, right? And if I say that it's a function, I mean that each input gets exactly one output. So would you write that down here? Just remind yourself each input gets, oops, that's guess, gets exactly one output. Okay, so not all rules have that guarantee. So we can graph things with x's and y's like circles. Remember we had that circle yesterday? Was that a function? No, so we would have to use x's and y's to graph that, because if we tried to do it with f of x, we couldn't, because f of x makes a promise that it's a function. Cool? Okay. So we have to evaluate this function at x equals 2, and then we have to find f of 1/2. So what we're going to do is telling us that x is 2. So everywhere we see an x, we're going to put a 2. So we say the output for 2, f of 2, equals 3 times 2 plus 1. So this piece right here, f of 2, means the output for 2. The output for 2. What this means is the output for 2 is given by this rule. So all we have to do is simplify using the rule, and we know the output. So 3 times 2 is 6, plus 1 is 7. So we say f of 2 is 6 plus 1, or 7. And we're done. The output for 2 is 7. Okay. Now look at this next one. Do you see that this 1/2 is in the x spot? You see it? It's like right in that little spot. Okay. So that's another way of communicating to you what x is. They can either straight up tell you x is 2, or they ask you to find f of 1/2, meaning the x is now 1/2. Cool? So this means that x is 1/2. So we just find the output for 1/2. F of 1/2 equals 3 times 1/2 plus 1. Okay, ask your calculator what 3 times 1/2 plus 1 is. So you're going to do 3 times, open parentheses, 1 divided by 2, close them, plus 1. And then math, enter it because you're going to get a decimal.
What was it again?
3 open parentheses, 1 divided by 2,
3, 1 divided by 2.
close parentheses,
Mhm.
plus 1. So 3 open parentheses, 1 divided by 2, close them, plus 1. I get 2.5, but that's a decimal, so I'm going to hit math. And then I want frac because I want to change it back into an improper fraction. I hit enter, enter. Thank you. So I get 5 halves. So the output for 1/2 is 5 halves. We can
get the 3?
from the function rule. So this is all part of the same direction. So it says evaluate this function at x equals 2, then find f of 1/2. So we're just using the same function rule that we used before. Okay, let's try another one. All right, so this time they want us to use this little function rule. Look at the degree on this little polynomial expression that I have in my equation. If we were to classify that by degree, what would we call it? That's by number of terms. Yeah, the other two. This is quadratic. Quadratic. This is actually a little quadratic function, if you can believe that. Okay, so we want to find f of 3. So the output for 3 is, okay, plug in the 3, square the 3, and then subtract 2 from that. So what's 3 squared? 9. So 9 take away 2 is 7. So we can say the output for the input 3 is 7. If I were to write that as an ordered pair, that would give me the point 3, 7, where the 3 is the x and the 7 is the y that I get when I plug in the x. Easy peasy lemon squeezy. Okay, so what we're going to find is that when we are dealing with functions, we can use f of x and y interchangeably. Okay, because if we're talking about functions, they are the same thing. Okay. Now we need to find f of negative 3. So I'm going to find the output for the input negative 3 is, okay, I have to square the negative 3 and then subtract 2. If I square a negative, what do I get? Positive. So just be really careful when you put this in your calculator because you're going to want to make sure that you put those parentheses around the negative 3. So I'm going to say open parentheses, negative 3, close them, power caret, square it. I get a 9, and then I have to subtract 2.
7.
Yes. If you don't put the parentheses around the negative 3, you'll get negative 9, and then your answer is going to be wrong. Does that make sense to everybody? Okay, perfect. So we got the same thing. 7. So we get this other point, negative 3, 7. That's why parabolas have this fun shape where they go like this, because there's always like these two places where they have the same output, the same y value, right? Comes from the positive and the negative x. Okay. Next up. So this is a fun little function rule. Do you see where the x is? It's in the exponent. If we have a x in the exponent like this, we're going to call that one exponential. Okay, so for right now, we just have to plug in the x though. So we want the output for the input 2. So we have to put in the 2 wherever we see the x. Okay, ask your calculator what 3 squared is. 9. Okay. We kind of already knew that, didn't we? So the output for 2 is 9, so that gives us the point 2, 9, where 2 is the x, 9 is the y. All right, now we have to do the same thing for f of negative 1. We need to find the output if our input is negative 1. So 3 to the negative 1 power. Ooh, negative power rule. So my negative power rule says that I get the reciprocal of my base, okay, with a, what kind of exponent? Positive exponent. So that'll be 1 over 3 to the first. Do I need to put that little 1 power on there? No. Yeah. So that gives us the point negative 1, 1/3. That's my x, that's my y, input, output. So if you give me an input and a function rule, I can tell you the output for that input. All right, now we're going to use that to fill in a table. We're just going to be doing the same thing though. We're just going to use the same rule over and over and over again to fill in these tables. Do they tell us what the x's have to be? So we really get to pick any x's we want, right? They're not telling us what they have to be. However, think about, what do most of the graphs look like that we give you? Are they like graphing a million? No. They're all centered kind of around the origin with nice little numbers like between negative 10 and positive 10, right? So let's pick some numbers right around 0 that'll be easy to do math on. Okay, we're going to call these our usual suspects. So we're going to start with x equals negative 2, and we'll go to negative 1, 0, 1, and 2. So if I don't specifically tell you what x's to use, this is where I want you to start. Because they're little, they're nice, they're easy to graph. Okay, you're not going to get crazy big numbers that aren't going to fit on your graph. These are the ones I want to see. All right, so now we just have to do each of these in the function rule. Okay, look at the power on this x. Can you classify this little polynomial in my equation by degree? Yeah, it's linear. Do you see that the highest power is 1, so it has to be linear? Okay, so I have to do g of negative 2 equals 3 times negative 2 minus 2. So on my calculator, I'm going to do 3, whoops, that's a parenthesis. 3 times negative 2, that's a minus. Make sure you use the little baby minus, not the subtraction minus. What is it? Minus 3 times negative 2? Minus 2? Okay. Minus 2. Okay. I got negative 8. Did you guys get negative 8? Okay, so I'm going to put negative 8 for my g of x. So when I plug in an x of negative 2, the output I get is negative 8. I can write it over here too. All right, now we keep going. So I want g of negative 1. So 3 times negative 1 minus 2. All right, ask my calculator. 3, open parentheses, times negative 1 minus 2. negative 5. Put that in my table. Okay, this next one is great. You guys will love multiplying by 0. 3 times 0 minus 2. What's 3 times 0?
0.
0. Take away 2.
Negative 2.
Negative 2. Good. Okay, next. G of 1. So the output for 1 is given by the rule 3 times 1 minus 2. 3 times 1 is 3. Subtract 2. 1. Okay, last one. G times 2 equals, G of 2. 3 times 2 minus 2. 3 times 2 is 6. Subtract 2, 4. You guys can handle that, right? Do you notice anything fun to see? Like, I know you're putting it in the calculator, but sometimes I push the wrong buttons. Do you notice anything fun in the table that would let you know if you're doing it right? What's happening every time?
Or up, added by 3. Because it's
Yeah.
going from negative to positive.
Yeah. We're adding another 3 with every x that we increase, we're getting another 3. So that's why we're adding 3 every time. Plus 3 every time. Okay, cool. Let's look at this one. Okay, basically we're going to do the same thing. So we're going to put in our usual suspects. Negative 2, negative 1, 0, 1, and 2. And we're going to plug them into our function rule. So we want h of negative 2. H of x and g of x are basically just like f of x. But sometimes we have different function rules at the same time. And if we called them all f of x or y, it would get really confusing, like which one are you talking about? So it's basically like being able to say, you know how people have different last names? It's like a way to tell them apart. All right, so we'll take negative 2 times negative 2 plus 4. So let's put that in the calculator. Negative 2 times negative 2 plus 4. I got 8. Next, I want h of negative 1. So negative 2 times negative 1 plus 4. Negative 2 times negative 1, that makes a positive 2. Plus another 4 is 6. Okay. What about h of 0? Negative 2 times 0 plus 4. Anything times 0 is 0. 0 plus 4 is 4.
Or just subtracting by 2.
You're subtracting by 2 every time. Yes. So h of 1, what do you want to bet that it's positive 2? And h of 2, the output for 2 is going to be 0. Now, do you see that both of these are linear? Check out my powers. Highest power 1, highest power 1. So this is going to be common anytime we have a linear function. We're going to have a plus something or a minus something every single time. Okay, we're going to call that a common difference or a constant rate of change. Okay, we're gonna do number 7 together, and then I want you to do number 6, okay? So put in your usual suspects, -2, -1, 0, 1, 2. So I want the opposite. So k of x is, just kidding, I want k of -2. K of -2 equals the opposite of -2 squared plus 1. So on my calculator, I'm going to say the opposite of open parentheses, -2, close them, square it. Did I forget the plus 1? Is there a plus 1?
Mhm.
Plus 1. I got -3. Did you guys get it? Make sure you're practicing on the calculator. Bless you. Okay, so I got -3. Next, I want k of -1. So I want the opposite of -1 squared plus 1. Opposite of open parentheses, -1 squared plus 1. I got 0. Okay, I want k of 0. So the opposite of 0 squared plus 1. What do we get if we square 0?
0.
0. Then take the opposite of 0. Still 0, right? Then add 1 to 0. It's 1. Did you get that on your calculator? Do I need to do it? Oh, you guys are so quiet today. That's fine. Okay, so k of 1 is the opposite of 1 squared plus 1. So let's put that one in the calculator. The opposite of 1 squared plus 1. I got 0. And then k of 2 is the opposite of 2 squared plus 1. The opposite of 2 squared plus 1. I got -3. Notice anything goofy? Any fun patterns popping out? Look at my outputs, my y values, my k of x's. You see anything strange? It's quadratic. All right, look at the next one. I want you to fill in the next one. I'll get you started with your usual suspects, and then I want you to do it. Just like